Object coder. Normalizing an object design. In other words, simplifying it. That's really what what we're talking about here. This is the key word here is simplifying. Simplifying. We use that word a lot in coding, and it's a golden word. All right. We're going to look here at an example. Without further ado, let's jump into it, huh? All righty. Let's do it now. Get rid of this and get back into example number one. Example number one, normalizing, simplifying, and object design. So this is how we start pretty much any project. We start off with a bunch of methods, maybe some classes listed. We need to code these three classes. We need to code all these methods, about 21 methods. That's a lot of work. That's not just a little bit of work. That's a lot of work. Let's see if we can reduce it. Let's see if we can simplify it. All right. Well, then the first thing we want to do is see what we have available to us, right? So we don't have to reinvent the wheel. Code that we already have available to us. And what we can see here is that in a nutshell, we have this code here. It's already available to us. So above up here, this code up here, we have the four classes that we can play with, we can use, and then these methods that they implement, that they service. So let's take a look. Here's the initial design, which is just a copy of the problem statement right here. First, we're going to just kind of get organized. So what we're going to do is we're going to identify these methods that are all the same and call them, give them a name, give them an alias, common one. What we end up with is this. So we need to code these three classes, and we need to code this group of methods right here. About 7 methods in each one, so actually 21. Okay, so finding reusable components. 1NF, first normal form. Finding reusable components. Okay, could components be added to provide required functionality so that we don't have to just code all this stuff? Can we have some components do it for us? Existing components, reuse. All right. So again, we're just kind of reviewing here. Here's our context. Here's our redundant methods now. Shape, that's an existing class that we can use, that we can reuse, has all these methods. If we line shape up here, along with the methods that we have to code, we see that we have an exact match for 5 methods. That's huge. That's about almost 80% of the coding looks to be already done by shape. So that's exciting. Let's take a look. All right, we're going to rename that group common one now and give it a new alias, component one. In other words, that component's going to do the work for us. Just an code organization type thing. And then we have these two. So let's take a look at our design now again, where we are. Here's our new design point. We have these 3 guys here that we need to code. They each have a group of methods here, about 5 methods, but the component's going to do that work for us. So we don't really have to worry about that. We're going to delegate. All right. And there's a couple additional methods, turn and forward. All right. Well, let's take a look now. Can components be added to provide the functionality based on what we just saw? Yes, they certainly can. We saw that they can be added to reduce that functionality greatly. They can do those methods right there, right? And take a look here. Take a look at delegated. Give that a read. A delegated method is a trivial method. As we know, most methods require an algorithm. They require testing. They require visual checks. A delegated method is much simpler. We just get the method call, move by vector, and we pass it to our component. We're just delegating it to our component, letting it do the work, and it is responsible for testing and all those things. So take a good read of delegated. Understand delegated really well. Also take a look at reuse here too. Take a good look at that. Okay, so these are our available components. We're going to give it a shot. Here's our classes that we need to code, and if you recall, we're going to have a component here now called circle here, rectangle, ellipse, and we're going to have these components here. So each will have a component. We're going to do a has a check, if you recall that. Circular turtle has a circle. Rectangle turtle has a rectangle. Those sound reasonable. That's just a check. If it came out with something like circular turtle has a road, that would be weird. So that would give us a red flag. But these sound reasonable, so we'll say they pass, and we'll go on. We'll continue on. So 1NF has been achieved. We've achieved finding a reusable component. And those three components are right there. And they're going to do all that work right there. So all we're responsible for right now, so far, is just these. Let's try this again here. That's not very clean, I would say. See if this is going to give us a little bit better. Yeah, these 6 methods right here, so far, is what we're left with for coding. So we've done some good improvements even so far. That's the first of 3 steps. Second step is we want to generalize the components. We don't want to use a specific component unless we have to, which there will be cases. So right now we do have specific components. We have a specific circle, a specific rectangle, a specific ellipse. However, there's a more general type here, shape. And it turns out if we take a look, interrogate shape, it turns out that shape actually implements all these methods. So shape implements all these methods. These specialized classes don't implement these methods. If they did, we'd have to do something. We couldn't do what we're going to do here. So because this implements all the methods that we need, we can generalize to that type. All right, just do this has a check again. Circular turtle has a shape. It's reasonable. All right, so now we've generalized it. Circular turtle, circle, shape, shape, shape. Instead of circle, rectangle, ellipse, we're making it into shape, shape, shape. All right, so how might we improve the component IVAR names? Shape. Shape would make much more sense, right? If we could change that from circle, rectangle, ellipse, that's a generalized guide right there. So why don't we just call that shape? This is the instance variable here, or a component. All right, 2NF has been achieved. So we now have these shape objects, and we have this code here. Finally, we're getting our last little piece here. Inheritance is not as big of an issue, as big of a hitter as component reuse, but it's valuable. So let's take a look at inheritance. First off, we ask the question: Do we have any redundancy of components or functionality that would allow us to say that we might want to use inheritance? Well, these are all redundant, right? This is 3 classes, shape, 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 they all have shape. These are all redundant, same methods here, turn, forward, turn. So it's completely redundant along all 3 of these. Circular turtle is redundant with circular rectangular turtle, which is redundant with elliptical turtle. A lot of redundancy. So definitely we can do some inheritance here. All right. So we're just going to check that they're all the same type. They are. Okay, trying a super type. So we're going to try turtle here. In other words, remember, we have to code a circular turtle, rectangular turtle, and elliptical turtle. That's our job. So now we're going to add this super class here called turtle. And we're just naming it turtle. We could call it abstract turtle or basic turtle or something like that, but just turtle. All right, do it is a check. Circular turtle is a turtle. Rectangular turtle is a turtle. Sounds reasonable. All right. So turtle IVARs. It has 1 IVAR, doesn't it? 1 IVAR there. Turtle behaviors. It has this set of behaviors here on the component, and then a couple here. Well, guess what? The 3 subclasses don't add anything. This is rare. This isn't going to happen all the time, but we can just actually eliminate those. Now that is a thing of beauty, because we have actually just simplified the problem down to 1 class now. Instead of coding 3 complex classes, we are going to be coding 1 simple class. We started off with coding, this was our initial project right here, 3 classes with lots of methods. We're now down to 1 class, just turtle. So we've achieved it right here. We have a class called turtle. It has 1 component or instance variable shape. It has some methods. Note these are delegated methods, And I encourage you again to go read about delegated and understand what those are, because those are really valuable. All right, let's look at the conclusions. Here was our starting point. Big blob of methods we had to code, right? Big blob. It looked like a lot of work. It really did. Um, this is our final design compared. We no longer have 3 classes. We only have 1 class. We have 1 instance variable or component that's going to be it's a reusable component. It's going to help us do our work, and it's going to do work for us. We're going to delegate to it so we can be lazy. And these are the methods right here that are going to be delegated to that component. These are all delegated. All right. So instead of 21 free methods, we have 5 delegated methods, which are trivial, and two free methods. So great simplification here. We're basically down to, this is our real work now, this remaining is 2 methods. So we went from 21 methods at the beginning to 2. That's a good simplification. And we'll talk to you soon.